Hi science fans, what is this? Which it won't focus on. What is this? This thing moves. Ooh. Well, I'll tell you what they are. They're resistors. You need to know lots about resistors for physics. AQA, trilogy, triple, foundation, higher. Need to know loads. So today I'm going to talk about resistance and resistors. So key things about resistance is anything that slows down a current, a flow of electrons. Okay, so it's anything that slows down a flow of electrons, and the different types you need to know are fixed resistor, variable resistor, thermistor, and LDR, light dependent resistor. You need to be able to draw them. You need to know what happens when they're in use, and probably you need to know the graphs that they produce with voltage and current on them. Now, resistance is measured in ohms, invented by Mr. Ohm. We're not very creative, and we calculate it by doing voltage divided by current. Learn that equation. It's not one they give you. Let's get cracking. Key things we need to know about resistance is it is measured in ohms, and it is voltage in volts divided by current in amps. Okay, and it is anything that slows or resists the current. Okay, now if I have a fixed resistor, which looks like this is something that has a fixed amount that it slows down the current. And if I put that on a current voltage graph, it will look like this, as long as the temperature stays the same. That's current and that's voltage. Okay, and then we've got these type of bad boys. This one here, if I'm drawing that, it looks like this. This is known as a variable resistor. And what happens with this is it will change the resistance depending upon how much resistance you put them under. So if I had this hooked up to a bulb, the bulb will go brighter because there's less resistance. The bulb will go dimmer because they're all dimmer because there's more resistance. So they're two basic types, and you would have that in like a dimmer light switch. Another resistance would just stop a huge flow of current running through it, so that it wouldn't be dangerous. I said a resistor is anything that slows down the current. I mean, it can literally be anything. So if I'm doing my diagrams, a wire could be a resistor because it slows down the current. The type of wire, the material the wire is made from could be, or if it's very long, it will increase the resistance, or if it's very thin, it will increase the resistance. And other things that could also be a resistor is any component in a circuit. So a bulb could be a resistor. Now, the things that we do know about bulbs, if we're going to do our graphs again, is that bulbs get very hot, and so when they get very hot they slow down even more, so they will produce a graph that look like this. There'll be more resistance the hotter they are because the particles are moving faster in the lattice. So let's have a look at these specialist ones. So we've got a LDR, light dependent resistor, and a light dependent resistor changes the resistance depending upon the amount of light that is shining on it. Okay, so if we've got a light dependent resistor, if there is a decrease in light intensity, there will be an increase in resistance. So these are quite useful for things like starting off circuits with security lights, where if you walk in front of them, they will increase the resistance, and therefore that would set off an alarm. The other one that we need to know that you'd find in things like kettles and immersion heaters is a thermistor. Now, a thermistor looks like that. And a thermistor is a temperature dependent resistor. And if its resistance will change. So for example, if we have an increase in temperature, don't ever write temp, you will have a decrease in resistance, and vice versa. So these two are going to have their own graphs as well, depending upon the temperature and the light intensity. So let's have a look at those graphs. Okay, here I have some terribly drawn graphs. So this one is showing if my temperature increases, so it's always going up from 0, what will happen to my resistance. So as the temperature increases, my resistance will decrease. Okay, which means that as the temperature, I'm going to write temp here, don't do that in the exam, as the temperature increases, the resistance decreases, which means that the current flow will increase. So the flow of electrons will increase. There'll be more in the wires flowing. This one is my light intensity, so this is to do with my LDR. Remember the shape of the graph, so I've measured these in lux, but they could give you any unit. So as the light intensity increases, the resistance decreases. So it's going to be like that. So if there's more light, there's less resistance, which means there's an increased flow of current. Boom. That's mostly what you need to know about the components. So you need to know LDR, thermistor, you need to know about fixed resistors and the shape graph they do, the filament lamp and the graph that they produce. There is a required practical for resistance, which is resistance of a wire, and you need to know the method and the expected results and why that happens, but that would be a different video. Another video that I would have to do is on how you calculate resistance in a parallel and a series circuit, but that is something so to look forward to in the future. More of my face. Good luck in the mock exams. See you later. Bye.